Hey everybody, my name is Chris and I'm a tutor here on Chegg.com, and I mostly do math and computer science, and in this video I would like to do a couple examples of using the second fundamental theorem of calculus. So the second fundamental theorem helps us take derivatives of things in this form here, or things like that. So before we can use it, let's go ahead and recap what it says. So the second fundamental theorem of calculus says, if f is a continuous function on the closed interval from a to b, then the function g defined by g of x equals the integral from a to x of f of t dt, where x is between a and b inclusive. This function g is continuous on the closed interval from a to b and differentiable on the open interval from a to b, and it's actually true that g prime of x equals f of x. Okay, so it's kind of a mouthful there. There's a lot going on, but it's using this is actually very, very simple. Using this is so much easier than saying and remembering what it actually is. So here, g of x equals the integral from -10 to x of cosine of 2t dt. So let's break this down in terms of the general formulation here. So a is the number down here. So in our case, a is -10. So here's our a, -10. And then f of t is the function inside of the integral. In other words, it's the integrand. So this right here is our f of t. So then g prime of x is going to be f of x. Okay, because that's the conclusion here, is that g prime of x is f of x. And well, if f of t is the cosine of 2t, then f of x is just the cosine of 2x. And that's actually it for number one. So it really is that simple. It's one of these things that's so simple that you might even be confused that that's really all there is to it. And yeah, so number two, though, gets a little more complicated, kind of tricky, still not actually too bad. It's the same idea, but here we have something a little bit different. So here we have a. Here's our a. Let's maybe use a different color. A is 3. Notice that in number one, we didn't use the fact at all that a is -10. The only thing that really matters is that it's a constant. Okay. Here a is 3, and again, it's not going to matter. It's just a constant. That's the main point. E to the t, that's now our f of t. But notice here, we have x squared instead of x. How's that going to affect things? Well, let's go ahead and see. So for number two, g prime of x is going to be e to the x squared, because we replace every t with x squared, okay, because now we have x squared instead of just plain old x. So every t in f of t gets replaced with x squared. So it's e to the x squared, and then we multiply by the derivative of x squared, which is 2x. Okay, so in general, here what we actually had, because we have x squared up here, then what we had was f of x squared times the derivative of x squared. Okay, and this comes from the chain rule. So here, if f of t is e to the t, then f of x squared is going to be e to the x squared. So that's where this came from here. And then the chain rule tells us that we have to multiply by the derivative of the x squared, which is why we're doing this. And the derivative of x squared is just 2x. Okay, so that's why we have e to the x squared times 2x. So then our final answer is just 2x e to the x squared. Okay, so that's our answer for number two. And this has been two examples of using the second fundamental theorem of calculus. I hope you found this video helpful, and thank you for watching.